I'm going to do a lesson on area of regular polygons. So, a reminder, regular polygons have all equal angles and all equal sides. So every picture here is a regular polygon. And in your book, you're going to see a lot of, or at least some new terms, like the term apothem. And the apothem is this segment that goes from the center of your polygon, which is also the center of the circumscribed circle. And it goes from that center to the side at a right angle. And so the area of a regular polygon is dependent on the apothem. So if you look at what I wrote here, it's the distance from the center of the circumscribed circle to one side of the regular polygon. It could be to any of the sides. So we're going to need to think about our variables here. Then they talk about n. N is just the number of sides. S is the side length. P is the perimeter. A is the area. Okay, so the concept of finding the area of a regular polygon is actually, it's really logical. You're going to just think of the polygon broken up into triangles. And if you just look a little bit more about that apothem, you can see that the apothem, it goes from the center to the side, but then that red radius of the circle, right, also goes from the center to the vertex. Okay, and so I put this picture together so you see the difference between the radius of the circle and the apothem of the polygon, but together those make triangles. And when we look at a regular polygon, there's always equal or isosceles triangles in the regular polygon. So like if it's a pentagon, there's 5 isosceles triangles. And if you could find the area of any one of those isosceles triangles, well, then you can find the area of the polygon. So this is actually very simple at first because the book gives you most of the values that you need. Eventually, you have to use trigonometry to find out missing values. And there's one problem that's a little higher level. So this is a very basic problem. So for this area of the Pentagon, the way I would look at it is that you have 5 isosceles triangles. And the base of this particular isosceles triangle is 2. And the height of that isosceles triangle is 1.3. So you have 5 times 2 times 1.3 divided by 2. So really, you just have 5 triangles, and each triangle has an area of 1.3. So that's 5 times 1 and 5 times 3/10. So that's 6.5 centimeters squared. So that's one way to do polygon area. That's usually the way I do it. There's also a formula, and we'll talk about the formula. But let's just go through the process one more time. So you have here a regular octagon, and within that octagon, there's 8 isosceles triangles. And the apothem of the octagon is 1.3 units long, and the radius of the circle, which is the side of the isosceles triangle, is 1.4. And the reason I gave you both of those is because sometimes the book's going to do that, and it's a distractor at this point. At this point, you're really not using that value. But I want you to get used to seeing that it's different than the apothem, And also I want you to be able to disseminate the information. So if you do have all those values, you know which ones to use. Okay, and similarly up here, we never used the 1.6, even though it was in the picture. So here, we're just going to do 8 times the area of the isosceles triangle, which is 1.1 times 1.3 divided by 2. And figure that out. So that would be 8 times 0.55 times 1.3. Okay, so that's because 0.55 is half of 1.1. And that would be a calculator active problem. Although it's not a hard problem, it's just kind of quicker. So let's go to standard here and just work that out. 0.55 times 1.3. So that's 0.715, and then times by 8. And that's 5.72. And centimeters squared. One thing that you can do, and we should check my work all the time, well, to check your work, you can obviously do it by multiplying 1.1 times 1.3, then dividing by 2, then times it by 8, and get the same answer. But also, you know the radius of the circle is 1.4, and pi r squared is the area of the circle, so that would be 1.4 squared times pi, and so your answer should be smaller than that, because the shape, the octagon, fits in the circle. And since I don't have the pi key handy and I'm just doing an estimate, my circle area is about 6, so it makes sense that my octagon area is a little bit smaller. Okay, so there's actually a formula for this, and basically the formula is area of a regular polygon is 1/2 the apothem times the perimeter. And another way you'll see it is 1/2 the apothem times the side length times the number of sides. And if you look at the first pentagon over there and we follow the rule, it works. 1/2 times the apothem, which is 1.3, times the perimeter, which is 10, because there's 5 sides. And in this case, 1/2 of 13 I still get 6.5. So there are times that you might prefer this formula. Some of you may just always think about it as 5 triangles. And then this is just the perimeter, the side length times the number of sides. So there's lots of ways to do regular polygon. You just have to come up with a way. So it's either multiplying isosceles triangles or using the formula. But you should be able to go and do backwards problems too. So like on this problem here, each side of the regular polygon has a length of 23.8 centimeters. And the apothem is about 16.4, so that would be about right here. And you're supposed to find the area, so that's not a fancy one. That's just one where you would just go ahead and use the formula, 1/2 AP. So 16.4 times 23.8. And then times the number of sides. That's my perimeter. Or you can think of it in triangles. And you would have essentially the same thing, because the area of one triangle is 23.8 times 16.4 divided by 2, and there's 5 of them. You get the exact same thing. So that's not really a going backwards problem. But this one is more of a thinking problem. That's what I meant to say, is there's a few harder things that you'll have to do in your homework. So here you're given the apothem, even though they don't show it, and that's why I want you to distinguish it from the radius. You're given the apothem of this octagon to be 14.5. Okay, and they tell you the side length is 12. And you have to get the area of the shaded region. So I would do a few things. I would look at this picture in isosceles triangles. In terms of isosceles triangles. And if it's an octagon, there should be 8 isosceles triangles. And there they are. And then I would figure out what fraction of the area is shaded, and there's 5 triangles that are shaded. So here you can just do the area of one triangle, and this is 12, whoops, it's not very oriented there, by 14.5. So the area, let's bring that into bigger view, of the shaded region is, of one triangle, is 12 times 14.5 divided by 2, so 6 times 14.5. And we have 5 triangles. That's one way to do it. So 6 times 14.5, 6 times 10 is 60. 6 times 4 is 24, and 6 times a half is 3, so 87. And we can double check that. 6 times 14.5, 87. And then we're going to multiply that by 5 and get 435. And it would be in feet squared. So one way is just to kind of logically reason your way through it. If you're a formula person, you know that area of a polygon we learned is 1/2 apothem times perimeter. So in this case, the area of the shaded region would be 5/8 of the area. I don't prefer this way, but it will also work. My apothem is 14.5, and my perimeter is 8 times 12. So that seems to me to be a lot more work, but it is a good opportunity to practice. No calculator math. The 8s cancel. 2 goes into 12 6 times. And so now I have 30. 5 times 6 is 30 times 14.5. And so 3 times 14.5 is 29 plus 14.5. Which is 43.5. So 30 times 14.5 is 435 feet squared. So that's just another way to do the shaded area. You end up with the same answer. That's using the formula. I kind of like reasoning through just with triangles. That's the gist of today. There's one harder part that we'll talk about in class, and that's going to be something we really focus on, and that's being able to find the area of a regular hexagon with only the side length. So even if the book gives you the apothem, I'm never going to do that. And so you're going to be able to do this problem just by being given one side length. Like if I say this is 8, you have to be able to do the whole area just off of that. And we'll talk more about that tomorrow, but the thing you should think about is that your triangle, your hexagon always has equal triangles, equilateral triangles in there, because this is 60 degrees. So they're all 60 degrees. So if you have 8 as your base, then you know this half is 4, and you know the radius is 8, and you can find the apothem with your Pythagorean theorem. A squared plus 4 squared is equal to 8 squared. So using that, you can find the apothem. That's not in your book yet, but it will be on your test. We'll focus on that tomorrow.